And here we are back once more with a little bit of algebra, Chapter 3, Section 8, and the final section in Chapter 3, Analyzing and Sketching Graphs. Okay, when analyzing or sketching a graph, there are a couple things that are notable, things to pay attention to. One is, where does it start out? Where does it end? And then what happens in between? Does it increase, as this does? Is it constant or no change? Does it decrease? And at what point does it do which one? All right, so we'll look at a few graphs. All right, these graphs show temperatures throughout the day in two cities. Here we have Belfast, Maine, and Newport, Oregon. Describe the change in temperature in each city. All right, in Belfast, Maine, the temperature does not start out as 0. Okay, it starts out fairly cold down here, and then it increases. And the increase slows down. It increases at a slower rate until about midday when it reaches its hottest temperature, and then it decreases faster and faster. Now the end point, notice, is higher than the beginning. All right. Newport, Oregon, the change in temperature, it starts out fairly warm and then gets colder throughout the day. So maybe they had a cold front moving in. And this is a constant rate. It gets colder at a constant rate, at a constant decrease, and then it hits a certain constant temperature, stays at that temperature, and then at the end of the day it increases again slightly, but the day ends up colder than it started. Make 3 comparisons. All right. Both of these, we will compare both graphs. Have an increase and a decrease. This has a section that increases and decreases. This has a section that increases and decreases. One graph Maine starts lower and ends higher, whereas Newport starts higher and ends lower. And both of these graphs are non-linear, whereas Newport has 3 sections that are linear. So from this point to this point, that is a linear section. From that point to this point, that's a linear section. And then the last part is a linear section. All right, sketching graphs. Sketch a graph that represents each situation. A stopped subway train gains speed at a constant rate until it reaches its maximum speed. It travels at this constant speed for a while, then slows down at a constant rate. Okay, constant tells me that that's going to be a line. All right, so for A, here we have the subway train. This is A. All right, since it's a constant, we are gaining speed at a constant rate. So we were stopped. That means we start at 0, and we will call this time, and this is speed. All right, and it gains. It starts at 0, gains speed at a constant rate, then stays at that speed, constant speed for a while, and then slows down at a constant rate until it comes to a stop, which means all the way back down to 0. Okay. B. As television size increases, the price increases at an increasing rate. Very important to note this. Okay, so we don't know, it doesn't say where it starts out, whether a tiny little television costs nothing or whether those cost something, so we can start pretty much anywhere, but then from where we start, the rate is going to be increasing at an increasing rate. So this will be the TV size here, and this is the price. Okay, price increases at an increasing rate. Very important, constant versus increasing rate. Okay, interpreting a graph. This graph shows the altitude of an airplane as a function of time during a trip from Denver to New York City. So we want to interpret this graph. Notice where it starts. It starts at 1, and this is miles. So it starts at 1 mile high, which Denver is 1 mile high. That's why they call it the Mile High City. And then the plane rises to an altitude of 7,000 feet in a half hour. This is 1 right here, halfway in between. So in 30 minutes, it rises to its cruising altitude of 7,000 feet. It stays at its cruising altitude for 3.5 hours, and then it descends at a constant rate until it reaches sea level, which is where New York City is. New York City is at sea level, and it spends 1 hour in descent. After 5 hours, it will have arrived at sea level. There's interpreting this graph. Okay, you might see a graph that, skipped a couple, that looks like this, okay, where we have a little segment there, and then there's a hole here, and it's filled in down there, and a segment on this side. Okay, we call this a piecewise function, and it's defined by 2 or more equations. So f of x is both x minus 2. It's x minus 2 if x is less than or equal to 0. And if x is greater than 0, then the function is 2x plus 1. So if I want to evaluate a piecewise function, they say evaluate this function when x is 0 and b when x is 4. So a, when x is 0, we check to see when it equals 0, then I have to use this one, this first one. So when x is 0, f of 0, we have to evaluate the first one, so 0 minus 2. When f is 0, function value is negative 2. Alright, and then when x is 4, greater than 0, we have to use the second one. So for b, f of 4, we're plugging into this one now. So 2 times 4 plus 1. F of 4 is 8 plus 1. So f of 4 is 9. And we can, that's 9. We can check that. Over here, 4, we would be way off the graph. Okay. All right. That's evaluating a piecewise function. Reading and interpreting a graph. So here you have an example of when you might have a piecewise function. Describe the seller's discount policy. The graph shows price per pound of animal feed when purchased from a wholesale seller. Notice in the beginning, the price per pound is $4 per pound. Now notice that this is an open circle because it's not if you buy 0 pounds. But immediately after the first few pounds, it starts at 4, and then at a constant rate it decreases until you get to 50 pounds. Okay, right there's 50. Those are significant numbers in this case. So it decreases at a constant rate. At 50 pounds, it drops down to $1.50 per pound. So the discount policy is as of 50 pounds, you only pay $1.50. Until then, it decreases at a constant rate. What are the domain and range of each price? So from 0 to 50, all right, the blue line has a domain. The x values are from 0 to 50. That's the x values. Now we have to determine, are 0 and 50 included? Nope, those are open circles, so greater than 0, less than 50. The range of the blue line, I should have used blue for this, is, there we go, the range is from 2 to 4. 2 is the smaller number, 4 is the greater number. Those are the y values. are those two included? Not in the blue line. All right, and the red line, the domain is from 50 onwards. So x is greater than 50, and now let's check to see, is 50 included? Yes, it is, so greater than or equal to. The range is just this value right here, so the range is 1.5, because y, or we could write y equals 1.5. And that's all we have for today, folks. Lots of fun. As ever, I will see you again in the next lesson.